Hi. Thank you very much. Welcome to day 2 of Google I/O, and thanks for joining me this afternoon. Hopefully the sun hasn't been too hard on your skin and you're not too sunburned. So today we'll be talking about Project Tango and why we're pushing on this technology, what we have today, and a little bit about, I want to share with you a little bit about where we hope to go in the future. The road ahead of us is really exciting, and I thank you for following us on this journey. Slides? Nice. Oh, okay. So when we open our eyes, something really amazing happens. Light and shadow enter our eyes, and a large part of our brain, our whole visual cortex, starts to go to work and interprets these signals into edges and shapes, and we start to build a memory of things. We start to recognize what our environment looks like. We know what our room looks like. We know what our home looks like. And we start learning the space around us. And as we learn our space, we start to get familiar with where it's safe to walk, where it's not safe to walk, and how we adjust our movements, even in the slightest way, to avoid bumping into things. And if any of you are parents, you are intimately familiar with or can appreciate the dangers and pains of misjudging your space around you, even just by a few inches. And some things in our environment are even more important to judge correctly. Even as adults, when the lights go out, we can sometimes take for granted that how important vision is to us. We start to fumble around and walk very cautiously. And the few inches can just be the difference between safe passage or a dangerous fall. So our ability to navigate our space is pretty fundamental to at least our everyday lives. So just a reminder, Project Tango is our focused goal to give our mobile devices and our tools this similar level of perception of space and movement. And ideally, ultimately, unify how people think about space and how our tools think about space. More and more, our phones have become increasingly sophisticated with more functionality. Nowadays, your phones used to be phones, and it's actually hard to remember that. But now they have cameras that let us augment our memory, communicate visually with friends and partners. The sensors, which humbly started to help just with automatic screen rotation, now, like accelerometers and gyroscopes, now provide the source of potentially health analytics and even activity awareness for pattern recognition and context awareness. And now we're getting accustomed to simply being able to unlock our phones simply by touching them. And this then becomes the foundation for mobile payments. So the ability to track position and track movement and measure the environment are such fundamental parts of how we operate as people that we see it as an inevitable direction. And in fact, we're starting to see consumer products coming out in the past 12 months that start to incorporate these capabilities of positional tracking that enable new user experiences or advanced computer vision to do collision avoidance in the drone space. So just a quick reminder, Project Tango devices give 3 capabilities. There's motion tracking, which is the ability to respond to physical movement, so when I walk forward, left, or right. Depth perception, which is the ability to measure the distance to floors, the walls, and surfaces. And area learning, which is basically the device's ability to have some spatial memory, to recognize places it's been before. And that can be used to help with drift correction or enable multiplayer experiences in the same space. Now, we've had a few sessions at Google I/O going deeper into some of these topics, so I won't be going into much detail here. But to achieve these new capabilities, we actually have to introduce new hardware. And if you've been following very closely, you'll be familiar with some of these. But I wanted to give you a sense that this started about 3 years ago with a drawing that looked like this, which is just a proposal for a tablet that had new sensors to do tracking, depth sensing, and inertial measurement units. And so a few months later, in 2013, we had our very first Android prototype. Now, it was a very clunky, bulky prototype, and it worked, but it wasn't very pretty. But you can start to see that it has the first components that we needed to do Project Tango. We have a sensor dedicated for motion tracking. We have integrated depth sensing, and then hardware-accelerated vision processing to do all the computer vision. A few months later, we pushed ourselves to drive down on size, and we started using mobile phone class components and mobile phone class cameras. And this is important for manufacturability and cost down, as well as power reduction. And so you may have seen these as white phones a few years ago. Then we decided to really push the limits on processing power with our tablet development kits. And this is what we showed off last year. These include, again, the same 3 components. And the specifications for this tablet were actually well ahead of their time. The specifications in terms of processing power and RAM and GPU capability are only now being matched by phones being released today, 2 years later. Over the past year, one of the things that we've been doing a lot is working heavily with Qualcomm to integrate support for these new hardware components into their Snapdragon processor board support package, or BSP. And for those of you who are familiar with how mobile devices are made, the BSP is a package of software that phone manufacturers, or OEMs, receive when they want to build a new phone. And so this required creating new hardware abstraction layers, new changes to the camera stack to allow not only the RGB camera to work, the motion tracking camera to work, and the depth sensor to work all at the same time, but also things like accurate timestamping. And so this means that any OEM that wants to build a Snapdragon-based phone will already have the major components they need to make a Tango-enabled device. So this unlocks the possibility for more phones, as well as more form factors, such as wearables and robotics in coming years. And we're eager to see the incorporation of these features into those products. Now, the first of these products is the Lenovo phone that we've been working with over the past year that you probably heard about from CES. And you can also see that it maintains the same pedigree in terms of the hardware components inside. We have the depth sensor, the motion tracking sensor, and our vision processing. Now, unfortunately, we won't be talking much about the phone today. You'll have to wait for Lenovo's Tech World in June 9th, in just a few weeks. But the event will be live streamed for those who can't attend. Now, the hardware is just part of the story. And in fact, most of the Project Tango team is composed of the software. So when you combine all this data, you have to put it together into a stack to interpret the signals into motion and sensing. So I wanted to give you a short video montage of some of the journey that we have from our very humble beginnings when we were a very small team to where we are today. If you could play the video. So I'm also really happy to say that we've actually incorporated the basic fundamental APIs for Tango into Android in. So what that means is that if you target an Android in device, you'll be able to see some new sensor types. You'll see the 6DoF sensor as well as a depth sensor camera type. And this means that you'll start to be able to write games that respond to the user's motion, or be able to write apps that can measure the environment, as some of the things you saw in the video. Now remember, it's important to know that these devices will only have the APIs enabled on devices that have the right hardware. This is similar to GPS. If you don't have a GPS module inside, the APIs won't be enabled. And on devices which meet our Project Tango specifications, there'll be additional libraries that help with things like area learning, depth, and meshing, as well as augmented reality samples that have to do with things like timestamping and alignment with the RGB camera. But the integration with the Snapdragon processor BSP, as well as integration into Android in, lays the groundwork for many, many new devices to come out with these capabilities. So let me give you some live demos of some of those components working in action. So we could switch over to the tablet and bring down the lights. Okay. So this is just a reminder of what's happening underneath the hood. This is our motion tracking sensor. You can see it's a fisheye camera with hardware accelerated feature tracks. And you see in the upper right-hand corner how it responds to movement. And so this is the underlying piece of what the 6DoF APIs will provide you if you write an app in Android in. And I can walk to this side of the stage, walk to this side of the stage, wave the device up and down. Oh, there we go. Wave it up and down, and it tracks. So one of the things we want to give to people who receive a Tango device, a bit of a tutorial on what it's like to have these new capabilities in their phone. So this is a sort of an out-of-the-box experience that we've built inside of Unity using our APIs. And so you can see it uses a depth sensor to actually provide a point cloud of the environment, and kind of illustrates the fact that we're indeed capturing a 3D model of this scene, and we have some visitors. And if we walk forward, we can get closer to them. You see the edge of the stage there. So as I look around, I can get closer to the flowers, and it starts to build this virtual environment around me with plants and creatures. And they were visited by some friends. There we go. So you can create really wonderful experiences when you combine all the different pieces together. You combine tracking with depth sensing and the pass-through camera to transition between a handheld VR experience and a handheld AR experience. Now, we can get down to perhaps slightly more utilitarian use cases. Actually, we want to keep the lights down for this. And so this is our updated measurement app. We just call it Measure It. And what it does is it shows another way of combining the APIs to provide value to the user. So if we wanted to measure the width of this cabinet, you can see that we actually have a slightly updated UI here. We have this circular reticle with this green dot that wobbles around. The reason why there's a wobble is because what it does is it looks for interesting features to lock onto. So when I get close to this edge, you can actually see it snaps to the edge of the cabinet. And what this does, it allows me to get a very good snap of that wall. We can also do something a little bit fancier. So let me place a marker there. And it also tries to maintain right angles. But what's also very cool is that we can now do volumes. So if I walk backwards, I can actually extract out a box. And you can see all the different measurements kind of overlaid onto the edge. So that's 2 feet 4 inches, thereabouts on each dimension. And if I take a picture of this, it'll save it to my gallery. And so if I'm working on some new cabinetry or kitchen work, I can simply take this picture. And you can see on the right side, it shows a picture on the left side, but in a schematic view on the right side, where it shows an orthographic view. And you can take this to the hardware store and say, this is approximately the size of the cabinets I'm working on. Now, being able to understand the physical size of things has been really interesting. So this is an app from Wayfair, who's one of the world's largest online retailers of furniture. And when you're shopping online for furniture, you typically have to scroll through a large set of thumbnails of couches and lamps, and you sort of have to guess. Oh, we keep the lights down for this, actually. You sort of have to guess, how big is it? Is it actually going to fit in my room? Do I have enough space? So what Wayfair has done is they've started working with furniture suppliers to acquire 3D models of the furniture in their store or their web store. So I have a small collection here, and we can select some items. And let me see how this chair looks. And if I pick a place on the floor, I drop it. That's the loading progress bar, and it unpacks the box in front of me. So again, we get all the correct dimensions of the chair. We can look at it from different angles. We can decide if we like the fabric or how many chairs we can actually get into this space. So let me pick another item. You can see I have this little lonely table right here. So let's pick this lamp. Okay. Again, that's a 3D progress bar. And we can lay down the lamp on top of the table and do the same thing. Now, you'll notice at the bottom, there's actually this shopping cart with a plus button. I'm not connected to the Wi-Fi right now, but that button actually works. It'll actually populate Wayfair's main mobile app, and you can then make the purchase there. So this actually helps a lot because one of the problems with online retailers is, especially in the furniture space, is that you often get a lot of returns. And so what this can do is prevent or reduce the amount of issues that you'll have. Now, we want to keep this one, we can keep the lights up. So you'll see I actually have this other little toy here. And one of the things, of course, we can do measurement and shopping, but another thing that we can do is games. Now, some of you at I/O last year may have seen a version of this kind of mechanic, but this is a demo where it's a much simplified version to kind of give you a sense of the subtlety and the type of interaction you can enable. So the volume may be a little high for this one. We'll check. We'll see. Okay, there we go. So this is basically like a target practice game. And you kind of imagine you're in a training scenario. And I can look around and see all the different targets. Now, if I just stand in one place and pull the trigger, it actually shoots this sort of kickball back at me. I see this red ball, and it comes and hits me back in the face. Now, in order to do well in this game, you actually have to dodge the ball that comes back. So if I shoot and take a step to the side, you can see that the ball goes past my head. So if you actually really want to do well at this game, you have to constantly move. And then you can also see there's this tree here that you actually have to look around to see all the targets. So that's just another example of sort of the range of experiences you can do. Okay, I get to get the device out of the rig. There we go. So this last demo is actually from the American Museum of Natural History in New York. And what they have there is an exhibit on the evolution of dinosaurs to modern birds. And this app was built in conjunction with the help of Guide2Go. What they've done is they've taken, sorry, I'm a little bit out of breath. Whew. But what they've done is they've taken the assets from their exhibit in the museum and allowed you to create an AR experience at home with those assets. So let's bring the lights back down. Okay. So what we have on the right is actually similar to the furniture shopping app. You can now search for dinosaurs. So we all love the Velociraptor. It's a very, thanks to Jurassic Park, it's a very well understood creature. So the polygonal model is actually the aesthetic style they chose for the exhibit. And they chose it to maintain sort of scientific accuracy because they don't actually know the exact details of the skin texture. And so rather than have a false texture, they decided to give a more abstract figure. So you can see he's here in front of me. He's interacting. If I push this little plus button on the right, he actually pauses and gives me some these info buttons. So if I walk up to the tail, I can click on it, and it gives me a little bit more information about this particular feature of the body. Or I go here and I can learn a little bit more about his wings. Now what's also cute is, if I could have my lovely assistant come up, Clay Bavor. Let me start it over so the animation will play. Is that they've actually added this little camera button in the bottom. And you can essentially do sort of dinosaur selfies here. Here you go. 3, oh, here you go. 3, 2, 1. There you go. And then email this to your friend. Thanks, Clay. Great. Actually, this one demo, we'll see if it works. I actually didn't test this one quite as much, but if it works, it'll be fun. So some dinosaurs are big. There you go. So he doesn't look too big, but if you look in the upper right, that's because he's at 20% size. And we have this little plus button here, and we can start to get a picture of exactly how big he is in real life. There you go. Hey, buddy. There you go. Yeah, he's harmless. He's friendly. Okay. So let's go back to the slides. So you just saw, 5 or 6 demos of apps that are either already in the Play Store or in progress for launch later this year. And this is just a small selection of dozens of apps that are already in the Play Store. So I want to give you a quick little montage of some of the other apps that are in progress that I didn't have time to demo today. So you can play the video. So just a reminder, if you want to build a Project Tango enabled app, you use standard Android development processes and tools and publishing. Your app just goes up on the Play Store, and your app has access to the APIs and detects them if they're on the device. So we have C, C++, Java, Unity, and Unreal support with sample code. And you can actually write one APK that you can distribute to all Android devices. And if you have the right code in it, if it gets downloaded on a Tango-enabled device, you can check for those APIs and unlock new features in your app with a single distribution. So that's kind of where we are. But obviously, the thing we started with Tango is something sort of a journey. And we're definitely not done with that. Because we're very much in the early stages. And I know almost everybody says that. But I actually really believe that. We're really just starting to scratch the surface. These APIs just start to unlock very superficial capabilities of what you can start to do with basic movement. But completely understanding our environment and the objects in it is actually still an open challenge. For example, I know that the podium here has walls on the back sides of the podium. But my device actually doesn't know that yet. The step sensor only tells it about the front surfaces. It also doesn't know that the podium is potentially composed of many, many different objects. There's a shelf here and some equipment underneath. And it treats it basically as one large set of geometry. So we also can't tell what, for example, what the amphitheater might look like at night, simply by seeing it once during the day. And that's something we've developed this immense human capacity and experience to actually be able to do. And these problems aren't actually going to be solved in the next 1 to 2 years. So we actually view that it's similar to these other efforts of working on improved speech understanding so that you can have more sophisticated interactions with just your voice. We can allow cars to navigate traffic and safely transport us home. Or investments in machine learning like AlphaGo to tackle increasingly difficult or ambiguous problems. So the Project Tango team is invested in focusing on giving our tools this perception of space and movement at a human scale. And we actually believe we can't do it alone. The challenges here are so large that many of the things, just like the ones I described to you, are built on decades of research. And Tango really is no different. Some of the same concepts used in our sensor fusion stack have pedigree in the work done for space exploration and robotics. The researchers had to combine the raw data from the cameras and the IMU data on the rovers to estimate its motion on Mars. And even some of the researchers that worked on this original rover are involved in Project Tango in various ways. So we stand on the shoulders of giants. And taking on this understanding is really no small task. And it's actually the reason why we maintain a very open collaboration with research partners. And in fact, we have over 10 research partner institutions, either research labs or universities, that we fund for doing research work. Over 26 conferences, conference journals, conference papers or journals, and 25 PhDs and master's students in various ways have been involved in the project, all contributing over 50,000 lines of open source code. Now, I want to show you a quick video of things that are in progress or in development as part of these research efforts. Some of these are done internally, but also some of them are done by our external partners. And these aren't things that are sort of committed to the product roadmap, but they're very much thinking about the direction we want to go and things we hope to one day become mature enough to be developer tools. So if we could play this video. So just as with the introduction of GPS, it enabled new industries and new functionality that wasn't really possible before. But as these technologies find their way into phones and into our pockets, it suddenly became possible to navigate new spaces. You can now press a button and a car will appear and drive to you. You can find the nearest pizza or find a friend nearby. And the impact of the technology far exceeds what it was first initially conceived for. And so we imagine, like, wouldn't it be great to have a tool that allow you to find rooms and places that you've never been to before? Or wouldn't it be great to have a device that could help the visually impaired navigate through spaces with greater confidence or greater independence? It'd be great if emergency workers had a tool that could let them estimate the positions of their teammates in a disaster area in real time. Or it'd be great to have the ability to walk through stories without tethers or cables. It'd be great if we could increase the speed or efficiency of package delivery, or even allow supplies to reach remote locations. And one day, it'd be nice to have robotic systems that share our perception of physical space to be better collaborators with their human counterparts. So we're seeking people who want to build the future with us, and we want to find colleagues in this space. So just a reminder, everything you just saw, including the things in the research video, were done with our Tango tablets and the data that they're actually able to capture. And these are available on the Google Store today. You can find the link from our website. And later this year, we'll see the first consumer device with these capabilities in it with the project with Lenovo. I also want to give a shout out and thank you for all the partners that we have demoing here at the Sandbox or were participating in the panel earlier today. If you haven't had a chance to go to the Sandbox, it's, I think, right by that corner, and you can try some of the demos. In the after hours this evening, we also have a treat for you. We actually have a 20-person multiplayer game where you can battle against aliens in a game called Fantageist from Trixie Studios. It'll be at 8 p.m. in the Cassiopeia tent, which I think is in that direction. So that should be fun. There's also a dedicated session tomorrow on making 6-degree freedom gaming with Project Tango. So I encourage you to see that tomorrow at 10 a.m. And we want to help. Now, we don't have an infinite number of people on our team to do it, but there's some mechanics, ways that we try to help you create really great apps. First of all, we have periodic workshops. We have developer engineering support. We also have the opportunity to feature your app on devices that may be coming out, or featuring it in our Tango app portal if you work with us. We can connect clients with partners. We talk with a lot of different companies, and sometimes people have assets and they simply need a viewing application, or there are opportunities for connections that we might be able to help with. And periodically, we have application RFPs or even competitions we'll announce. So to keep in touch, we have our website. We have our support email. We also have a reasonably robust Google Plus page with over 8,000 developers regularly posting updates about related news as well as their own apps, and our Twitter handle. So I'll leave this page up for those of you that want to take a picture of it, but thank you very much for coming.